QBASIC, welcome back everybody. I'm Prakash Pradhan, your trainer for this entire series. In previous video, part 1, that was the first introductory part of QBASIC for the long journey. We talk about the variable, the meaning of variable and the types of the variable and the rules for naming a variable and different types of variable along with the suffix. Now in this session, we are going to use the practical implementation of all the types of variables that we discussed in our previous session. So if you have missed out that, I suggest you to go through it. Now without wasting much time, so let's jump ahead to the practical implementation of those theoretical portions that we discussed for the variable and its detailed implementation. Now if I store a value in a form of integer variable, if you remember 30,767 is the maximum. So for example, if I say that let a percentage, that means integer, is 32,767. This is the positive value that is allowed in order to store in an integer numeric variable. Now, if I run this program, you'll notice that it's going to display the exact value that we printed or executed or stored in a numeric variable. But what if I try to exceed the limitation of this? Let me make it 68, 30,768. As per the rule, for storing a numeric value in terms of your integer numeric variable, it was not allowed. That means it should go for the negative value. So if I go to the next line and I run it, what it says? Overflow. Why? You're trying to store a value that is overflowing as per its capacity. So how will I make sure that this can store a negative value 30,768 as per the theoretical portion we have already covered? So if I give a minus, then trust me guys, it's not gonna show the error. See, 30,768 is the maximum negative value it can store that we discussed in our previous session. So the first variable is done. Now, what if you'd like to store a value that exceeds the limit of 30,767? What if you'd like to store a value having something like 10 digits? In that case, we'll have to use another type of variable that we call a long integer. So long integer can support a value more than 30,767 positive value. Okay, so if I go for, let's say 1, 2, 3, 4, 5, 6, 7, or let's go 8, 9. So it's gonna accept it easily. If I execute this one, okay, let me go to this one, and if I execute, you'll find it is not going to show any kind of error. So 1, 2, 3, 4, 5, 6, 7, 8, 9 digits are printed automatically because we are still in a limit. So how many digits it takes? Actually 10, not more than that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 altogether. Okay, and the highest number of digit, I mean to say that it is going to store that we have already discussed in our theoretical portion. Now, the next type of variable that we need to understand over here is that your single precision. That means what if you'd like to store any value having a decimal place value. Okay, now if I wanted to store a decimal place value, then I need to use the exclamation mark because this indicates your single precision numeric variable. For example, let's say 1.12345 it will support 6 without any error. So if I go for the A exclamation, I print it, trust me, it's not going to give any error. See, it's printed. But what if I exceed the limitation? Because I told you up to 6 digits it takes actually, including the first one, not more than that. So if I exceed this into the 7, 1, 2, 3, 4, 5, 6, 7. After the dot, after decimal, we are going to use 7 digits. So what's going to happen? Let me run. If I go to the next line, you see magic. It already changed into the double precision. If I run this value, now it's going to accept. Why? 1, 2, 3, 5, 6 is missing. But it's not going to give you any error because it has already understood that you are trying to store a double precision value with the help of the single precision numeric variable. So that's why it's going to skip one value. Have a look again. See, 1, 2, 3, 4, 5, 6 is missing. So if you'd like to execute the exact value, in that case, you'll have to provide the appropriate value in a variable. This is very mandatory to form the base of your QBASIC programming, which might not have noticed in school, but you'll have to do it. Okay, now what if like you're saying that no, I need to store a value more than 6 decimal place value over here. Of course, we do have a double precision numeric variable that we have already discussed. So if I go to double precision numeric variable suffix, and don't forget you'll have to use the appropriate suffix. So in that case, let's see 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now if I execute, is it going to execute? Obviously, no doubt. See now. So these are the simple rules, my dear students, that you need to understand whenever you said, you want to form your base strong in order to be a good programmer, at least in a QBASIC. Of course, the QBASIC is going to help you to understand the rest of the all high-level programming language that I often talk in a class, because it's not sure that this video is going to be viewed only by the student where I'm working currently. It's for my other old students as well. Anyone whoever are interested to understand how QBASIC works. So I do believe I made it clear the 4 types of numeric variable, that is a integer, let me write, integer, long integer, single precision, and double precision. Okay. Now the next type of variable we talk about in our theoretical portion was the string variable. So the string variable is able to store the alphanumeric value. That means we have discussed that with the help of string variable we can store any type of value including the blank space. So let's say $, of course we have already discussed that the string variable must end with the dollar, so that's why $, is used, and it's not mandatory to use all the time A, because we have discussed that we can use the 40 characters as a variable. So if I write a value, let's say just a one word, okay, I would like to print $, because in this $, only I have stored the value, and if I execute, there's no error, it's gonna execute as it is. Okay, spelling is wrong. What is that? Print, that is not pin. Okay, now if I run it, see, it's printing. But don't forget the rule. What was the rule? Variable must end with the $sign in order to execute the value. That seems to be the string value. If I remove this double quote, then it's going to show the error. Okay, so that was the rule which I have clearly explained in the theoretical portion. That's in the first video. Now, if I say that string variable can store anything, any type of data. So in that case, 1, 2, 3 @ and even the letters, including the blank space 1, 2, 3 ABC. Will it accept? Let's see now. Definitely it's going to execute as it is, because I told you anything you write or anything you store within a double quotation mark, it's going to be treated as a string value. But you also need to make sure that the variable that is going to support over here should be string variable. That means numeric variable, numeric type of data, string variable, string type of data. String variable can take both the data. String variable can store numbers also, symbols also, letters also. That I have already proved over here. If you want me to run it again, it's going to give the same output. But the numeric variable can store only the numbers. Don't forget that. And on top of that, when you use the numeric variable, you also need to make sure that the appropriate suffix is used. If you miss out to write the appropriate suffix, you are gonna come up with the error that is already sent by you. So I hope it was a bit informative to you in the long journey of this QBASIC. So we discussed about the variable and we saw the practical implementation of executing all the values along with the variable and its suffix. So if you find it fruitful, please do like and subscribe and wait for my next video. Thank you.